Okay, section 3.8 is derivatives of inverse trig functions. If you have a function f and it's differentiable at every point, and f prime of x is never 0, then the inverse has a derivative at every point in the interval. Draw your attention to this part right here. F prime of x is never 0, then f inverse has a derivative at every point. Why would we have to specify that f prime of x is never 0? Think about that. The derivatives of the inverse trig functions, there is a way to show how these formulas come about, and I'll probably show you guys in class. However, notice that the inverse sine, the inverse tangent, and the inverse secant have these derivative rules. Let's just talk about the inverse sine for just a second. The derivative with respect to x of the inverse sine of a function u, and we'll say u is a function of x, is going to be the derivative of u divided by the square root of 1 minus u squared. And you'll notice then that the derivative of the inverse cosine is just going to be the opposite sign of that. Okay, so technically there's only 3 to memorize, and then you just have to remember the negatives that go with it. Again, just like when we did derivatives of trig functions, all the derivatives of the c's, so the inverse cosine, the inverse cosine, cotangent, and the inverse cosecant, those are all going to be negatives. Okay, so these are 6. You've got to have them memorized, and again, I'll show you how they come about in class. Let's go ahead and take a look at the first example. If you're a memorizer, you're really going to like this section because it's just applying all of these rules. So the first one is find dy dx if the function is the inverse sine of x squared. Okay, so this little piece right here, that is our u. Okay, so dy dx, wow, my marker is very thin. Let's try that again. Okay, so dy dx, oh yeah, that's much better. Dy dx is going to equal the derivative of the argument, so that's going to end up being 2x, so the derivative of u, divided by the square root of 1 minus u squared. Now, if this is a free response, you're done. Free response answer is right there. If you're talking multiple choice, it would just be cleaned up a little bit, and they would say it was 2x divided by the square root of 1 minus 4x squared. That's it. It's as simple as that. Now we're actually going to skip example 2. This is something that we'll talk about after we do section 3.4, so we will come back to this one, but let's go ahead and move on to the next page. Okay, for the next example, we've got y equals the inverse secant of 5x cubed, find dy dx, and the derivative of the inverse secant is going to be the derivative of the argument, so that's the 15x squared, divided by the absolute value of u times the square root of u squared minus 1. For your response and you're done. Multiple choice, a little bit more work. 15x squared divided by 5x cubed in the absolute values. Square root, this is going to be 25x to the 6th minus 1. And then the last thing, the absolute value of 5 you can think about is 5 is always positive, so you can reduce the 15 and the 5 and just get a 3x squared on the top. And we're going to leave the absolute value of x cubed in the denominator. That's it. Okay, one more example and you guys are done. So example 4, the derivative, it's the opposite sign of the derivative of the argument, so we're going to get 6x over square root of 1 minus u squared. And that is it. If it was free response, you were done before, but if this is multiple choice, you would just end up with 1 minus 9x to the fourth on the denominator. And that is all she wrote. That's the whole lesson. So fairly straightforward, and if you have any questions, again, we'll go over that previous example, but that's about it. So get them memorized. Okay, bye!